talking on the other side of the camera to you guys today. Teacher Lee just had a bit of a family emergency and she couldn't join us today, but I'll be taking the class for her. We will be doing some revision on probability. We're doing Venn diagrams and tree diagrams. And we're just going to start off with something a little bit simple. If we could read the question on the screen, and we will try and answer question 8.1 together, and then I'll give you guys a chance to do 8.2, and then we'll discuss 8.3 together. Okay, so I hope my English voice is okay, Neliswa. I hope it's good. Okay, I'm going to try and read it with as good clarity as I possibly can. All right, a bag contains 6 red balls, and what I like to do is I like to highlight everything in the color that we've been given, so it just gives us a bit of a reminder. We've got 6 red balls, we've got 8 green balls. Now I have to find green, there we go. 8 green balls and an unknown number of yellow balls, an unknown number of yellow balls. The probability of randomly choosing a green ball, a green one, is 25%. Okay. Question 8.1 says, show that there are 32 balls in the bag. Does anybody have any idea how we can tackle this question? Good, Diana. We're definitely going to be using that 25%, but what exactly would we do with it? Okay, good. 25 over 100 times 6. But remember, we've got 8 green balls. There are 8 of them. So we need to somehow use the fact that there are 8 of them over the total. Yes, over the total of balls that we don't know in order for us to use that 25%. But I absolutely understand where you're coming from. What I would do in this case is I would cross multiply. So I know that 25%, as Diana is saying, 25% is the same as 25 over 100. And that would be equal to the number of balls that we know for the green is 8 over some number that we're not quite sure of. For the total, we'll call it X. And then what I can do here is I can cross multiply. So just cross multiply that way, cross multiply that way, and we can solve for X. So if you guys can just solve that for me and pop your answers for X in the chat for me, and we'll have a bit of a conversation about 8.2. What are we thinking? Good. Awesome. I've got one answer in the chat. I wonder if I'm going to get any others. Thank you, Ntokozo. Thank you. Excellent, Kanyisa. Yes. 800 divided by 25 will give us 32. So we know that our entire sample space is 32 for this particular question. All right, let's read 8.2. It says, a ball is drawn from the bag. The color is recorded and not returned. And that's a very important part of this, that it is not returned to the bag. So that's something very important that we need to be aware of. And then it says, thereafter, another ball is drawn from the bag. The color is recorded and it is also not returned to the bag. Okay. It asks for a tree diagram to represent all the possible ways in which the 2 balls could have been drawn from the bag. Show the probabilities associated with each branch as well as the outcomes. Okay, that's quite a feat, and I'm hoping that we'll be able to do it. I'll give everyone about 4 minutes to get their tree diagram going. Before we do that, I think it would be helpful for us to write down the information we do have. We know that we have 6 red balls, so R is equal to 6. And we've got 8 green balls. So look at me not writing green properly. G for green is 8. And because there are an unknown number of yellow balls, that would just be the difference between 6 and 8. Because we now know that the total is 32, we can just say for this one, 32 minus 8 and 16, which would be 14. Therefore, yellow would be 18. Okay. And now we can draw our tree diagram from there. I'll give you guys 4 to 5 minutes to figure it out. Okay, I think I've given it enough time. All right, guys. Okay, let's talk about what's going to happen here. We know that we've got 2 events that actually take place. We draw the first ball out of the bag. So that's event 1, we're going to call it. And then the color is recorded and it's not returned. So we will have a different sample space for the second event, which takes place over here, event 2. So can anyone tell me in the chat, in our first event, how big is our sample space going to be? And in our second event, how big is my sample space going to be? Anyone got any idea?
Yeah, you can also unmute yourself if you don't want to send your answer in the chat.
Oh, I see. Okay. See, guys, I actually teach grade 7 and we don't unmute grade 7s ever. So this is a weird feeling for me that you guys can actually unmute yourselves and answer and ask questions. In my class, we don't do that. Otherwise, we would have a big problem on our hands. Okay, so we're going to have 3 events. We're either going to have a red ball that's drawn or a green one or a yellow one. So I'm just going to write here R, G, and Y. And we know that if we draw a red ball, the sample would be 6/32. That is the probability. And then if we drew a green ball, that would be 8/32, or you can even simplify that to 1/4. Or a yellow ball would be 18/32. But because we don't return the ball, that means that there will be 1 less ball in our bag, which means event 2, this would be 32. Event 1 would have 32 balls, but event 2 would have 31 of them. Because now we've got 1 less. We didn't return the first one that we drew out of the bag. So 3 things will happen in each of these. Either I will get a red ball again, or this time a green one, or a yellow one. Okay. Now, if I get a red one again, my probability over here will change from 6. There'll be 1 less if I drew a red one. So I would have 5/31. But my green one would stay the same. So this would be red, this would be green and yellow. The green would stay the same. So I would still have 8, but instead of 8/32, I'd have 8/31. And for the yellow, I would have 18/31 because there'd be 1 less. Okay. We'd have the same thing happen with green. Okay, I'd have red, green, and yellow. Then remember, guys, the red will stay the same. So the red would still be 6 balls because I would draw a green one and not a red one, but that would be over 31. And then the green would be 7/31 instead of 8. And then over here, we'd have 18/31 again. Okay, this would be red, green, and yellow. And you guys will excuse my handwriting. I feel like I'm cramping everything up in one space. Okay, then for the yellow, we would have the same thing again. We would have red, green, and yellow. And the red would stay the same. It would stay 6/31. The green would stay 8/31. Okay, that's fine, Ntokozo. I'll speak to you now. But then the yellow, because we drew it, will have 17/31. Okay, Ntokozo, can I take your question? Where did I lose you? Okay. Ntokozo. 7/31. Okay, so if you notice, Ntokozo, here in the middle, we're assuming what would happen if for the second draw, we took out a green ball. Now, originally, we had 8 of them, right? So if we had taken out a green ball in the first event, we would have 7 of them left in the next event. And that's why there is 7 of them left over here. Okay. So in the second event that we're doing over here, we're assuming that we picked a green ball in the first event. Okay, I hope that makes sense. Okay. Same with this, with the red one over here. With the red one, 5/31. The reason why it's 5 and not 6 is because we're assuming we took out a red ball in the first event. Okay, awesome. All right, then question 8.3. It says, calculate the probability that the 2 balls drawn from the bag will have the same color. Okay, now we have to look at where we would possibly have the same color again. Now, what I usually do over here is I will count the events that we had. So in this case, we'd have red and then red again. So red and then red. In the second one, I would have red, then green. In the third one, I'd have red, then yellow. So I can do the same for all of these, for all of them. Yeah, just okay. Then I'd have green and red. I'd have green and green. And then green and yellow. And over here, I would have yellow and red, yellow and green, and then yellow and yellow. Okay. Now, if they ask me, calculate the probability that the two balls drawn from the bag will have the same color, there are 3 places where that happens. Okay. If we look at it, there's red and red over there. And then we've got green and green over there. And we've got yellow and yellow over there. So we need to look at the probability of all 3 of those happening, the probability of all 3 of them happening. So we'll take the probability of red and red plus the probability of green and green plus the probability of yellow and yellow. But now when we calculate the probability of red and red, that would be the first probability. It would be 6 over 32 multiplied by 5 over 31. Okay, same with green. With green, we would have 8 over 32 multiplied by the probability of green, which would be 7 over 31. I hope I can trust you guys to give me an answer to the end in this one. It's a bit of a long one. Plus 8 over 32 multiplied by 7 over 31. And the last yellow one would be 18 over 32 plus, oh, multiplied, not plus, multiplied by 17 over 31. And if anybody has an answer for this, please just pop it in the chat for me. It's quite a long one. $49 over 124. Okay. I agree. Thank you, Kainisa and Nick. This would be 49 over 124. Okay. Can I get a thumbs up from everyone? How are we feeling about this first question that we've done? Kainisa says, okay, that's good. Is anyone else feeling okay? Valerie's feeling okay, and Liam. Excellent, guys. Oh, thumbs up or thumbs down. Yes. I'm just used to saying thumbs up. If you're not feeling that confident. Oh, Nick says I'm making it easy. Thank you, Nick. That's awesome. I'm glad you're getting it. That's awesome. Okay, thank you, guys. All right. Are we ready to try another one? I think we should try another. Okay. Let's try another one. I'm going to give you guys some time to look at this one. Let me blow it up a little bit more. Okay. This one is a little easier, I think, than the one that we just did. Okay. I think we're ready. I feel ready. I've got this one. Okay. The blue. Ooh, I'm gonna need blue and red. Okay. Let me use highlighters this time. 3 blue marbles. And I'll use pink instead of red. 2 red marbles. So definitely think about what your sample space is going to be. S is going to equal to something. Let's start there. Okay. I want to see if I can ask a favor of you guys. This is what I normally do with my original class. Normally when we're done with a question, we'll put a certain emoji in the chat. So once you guys are done, can I ask you guys to pop the brain emoji in the chat, just so I know that you guys are done and we can start looking at the questions. Do we normally put emojis in the chat, Teacher Nelisa?
We do. It's
Okay.
usually thumbs up or thumbs down. I
Oh,
know
is it a
that's
thumbs
cool
up or
as
thumbs
grade
down?
7. Because grade 7 is a vibe.
Grade 7 is, yeah, we're always having a lot of fun and there's noise and laughter and always having a great time. But yeah, okay.
Yeah.
Any
Our
emoji you
metrics are
feel
very
like
focused, straight
yes.
to the point.
They need to be, Teacher Nelisa. This is matric. We need to be serious. But it's fine.
Yeah, I feel like,
any emoji you feel like in the chat to let me know that you're done.
Yeah, I like the brain one.
Mm-hmm.
Let me see if I can find it though. Oh.
There we go. Oh, and Tokoza found it too. Awesome.
Awesome. Hey.
Nice one. I like that one. Thanks, Valerie. And Tulisile. Thank you, Pumelela.
Let's keep them coming. Come on, Matrix. Let's do this.
Give them some time. They're still calculating, Teacher Melissa. They calculate.
Oh, yeah.
Bridget, I wonder how we came to put that emoji.
Oh, I love the nitty one. Nia. You're the nitty.
Awesome, guys. I'll wait for 2 or 3 more and then we'll get going. Thank you, Pam. And Kamisa and Ibrahim. All right, guys. Okay, let's have a look at these questions. All right, so they already tell us that 2 things are going to happen. Remember, we call them, this is the first event. The marble is taken from the bag, then it is put aside. So we already know that it's not going to be put back in. So that's our first event, event 1. And then a second marble is taken from the bag and it is put aside. This is event 2. I think I may have written them too close to each other there. Event 2. Now, somewhere between event 1 and event 2, my sample space is going to change. So if I have to draw a tree diagram for this, I'm going to have 2 events. I'm either going to get a blue ball or blue marble or a red marble. So that's blue and red. For my blue marble, because my sample space altogether is 5, for the blue marbles, I'm going to have 3/5. And for the red marbles, I'll have 2/5. Now, if, for instance, we pick a blue marble the next time, then I'll have one less blue marble. So the probability of me choosing a blue marble the next time will then go down to 2. But because we didn't replace that first one, my sample size has also changed to 4. And for the red, my sample size will change to 4, but I will have, I'll still have 2 of them in there, not 1 yet. On the other one, we'll have 1. 2 over 4 as well. Okay, and for this one, this would be blue over here and red over here. Then if, for instance, we take out a red marble instead of a blue, my blue would still be the same. That would be 3, but my sample space would change to 4. And for the red, if I've taken out a red marble, I'll have 1 left, so 1 over 4. It changed because we put it aside in Ntokozo, we didn't actually put it back into the bag. Okay, so we need to be careful for things like that. Okay, we need to read the question. If they said it was taken out, recorded, and then replaced, then that means that our sample size will not change. Okay, so we need to be quite careful with that. Let me just finish up here. This would be blue over here and red. Okay. Then it says, determine the probability of first taking a red marble and then taking a blue marble in that order. And that's a very important phrase, in that order. So we cannot just go and look for where we have a red and a blue marble. We have to look for it in that specific order. So first a red, then a blue. And where we're looking for that is from, let me just see if I can highlight the path. It would be red and then blue. It would specifically be this path over here. The red and then the blue. I should have done this rather. Red and then blue. And over here, this would have been red and red. This would have been blue and red. And this one up here would have been blue and blue. Now, this is the path that we're looking for. So can you guys tell me, if we had to calculate for red and then blue in that order, what would we get? Kanyisa says 1 over 5. I wonder if everyone else agrees with her or him. I'm not sure if Kanyisa is a character. Thank you, Kanyisa. Oh, Makosandile says 3 over 10. And so does Emiche. Let's see how this goes. Nick says 3 over 10 with a question mark. Nick, are we sure about that answer, or are you asking me or are you telling me? Dumeleng also says 3 over 10. Okay, let's see how we could possibly get 3 to 3 over 10 or 1 over 5. Let's see. So if I had red first, I would have gotten 2 over 5 multiplied by blue next, which would have been 3 over 4. And this would give me 2 over 5 multiplied by 3 over 4, which is indeed 3 over 10. 3 over 10. Very well done, guys. Okay. Amazing. This is some easy stuff. That's okay, Kanyisa. We just need to be able to read the questions, especially when it comes to things like probability. The way that things are phrased is very important, and we need to be able to read through them. Okay. It's no stress, not a stress at all. This is how we learn from our mistakes. Thank you, Nick, for that attitude. I'm loving that. Awesome. All right. Are we ready for some Venn diagrams? I think we should do some Venn diagrams. How do you feel, Teacher Neliso? Are you ready for it?
Yeah, I'm ready.
Yeah, I think we've mastered how to do tree diagrams, and now we're going to look at Venn diagrams. I just want to blow this one up as well so we can see it. And center it a bit. Okay. I'll give you guys some time to read through the question. And if you can, once you're done reading, please pop the nerdy emoji, the nerdy guy emoji in the chat for me to show me that you're done reading. And we can take a stab at answering the question. Thank you, Dimele. Diana, what did you do? Oh, Diana, sometimes you just need to zoom in or out. Just have a look. Maybe you need to zoom in or out. Okay. Oh, Kinsani is giving us the cool emoji. Oh, Diana, if you're on your phone, swipe left or right. Sometimes it happens. Swipe left or right. You'll find that you've swiped. There we go. Yeah. Oh no. Sure. Okay. Oh, Teacher Lisa, do you think you can help her out and try and figure it out?
Yeah.
We'll blame the iPhone. We'll blame the iPhone. When you're done reading, Nick, not when you're done completely. Okay. While Diana tries to figure out her problems there, hopefully she can take a screenshot when she's done. We're going to quickly draw our Venn diagram as question 1 asks. That's okay. That's all right. So you can double check, okay, as we go along. All right. So we know that we've got, okay, we've switched off. Have we switched off the waiting room? That's fine, Diana. You can come in and out and come back in. Okay. So we've got 3 events, guys. We've got rugby, and we've got volleyball, and we've got chess. Okay, so we're going to need 3 circles. Oh, no, look at what I've done now. There we go. Okay, 1. Oh, Teacher Annalisa, I'm doing great today. I don't know what's gotten into.
You're doing so great. Chris Jenner will say, "You're doing great, sweetie." You're doing amazing, sweetie.
Oh, there we go. Excellent. All right. Okay, so we'll have 3 events, and we'll just call the first one rugby, and then volleyball and chess. All right, now let's put some information into this bad boy. Okay, 52 learners like rugby, 42 learners like volleyball, and 5 learners like chess only. Now that only over there is very important. Okay, that tells us that we can already put 5 in this block here for chess, okay, because it's chess only. All right, now we don't know very much about this 52 learners who like rugby and this 42 learners who like volleyball, because the kids who like rugby can also like volleyball and they could also like chess. It doesn't mean that they only like rugby or they only like volleyball. Okay, so we need to make sure that we're not rushing to write 52 and 44 in the 42 in the volleyball and rugby place. Okay, then it says 14 learners like rugby and volleyball. So we're going to look for the intersection of rugby and volleyball, and we're going to put 14 in there. Okay, that's where it is. Then we've got 15 learners who like rugby and chess. So we're going to look for the intersection of rugby and chess, which is over here, and we'll put 15 over there. Wait, no, I'm lying, teacher. Oh, I'm lying. 12 learners like rugby and chess, not 15, 12. Sorry, 12 learners like rugby and chess. And then 15 learners, that was rugby and chess, 15 learners like volleyball and chess. There we go. I'm glad I caught myself. There, 15 learners like volleyball and chess. And then X learners like all 3 types of sports. So we're going to put X right in the middle because it's the intersection of all 3 of them. Okay. Then 3 learners do not like any sport. That means our 3 learners sit right on the outside of either of our circles. Now, what I usually like to do is I like to write S is equal to 80 here to remind me of my entire sample space. It just makes it easier for me to remember. All right, then it says, question 2, I think this was done. You guys can check on your Venn diagram if you've drawn it, if it looks like mine, it should, okay? Then we still need to figure out what rugby is and what volleyball is. Now, this is going to be a bit tricky because we don't know what this X here in the middle is. Okay. But because we know that 52 of them like rugby, we have to have 12 plus X plus 14 plus whatever this over here should be, and all of that should give us 52. Now, that's a bit more convoluted to find if we don't know what this thing over here is. Okay, I'm going to put an R there. Excellent. Okay, I'm going to put an R here. Okay. So what's going to happen, or maybe let me write it down here so it's not so messy. 12 plus X plus 14 plus rugby is equal to 52. But now, because I want to figure out what rugby is, what I'm going to do is have rugby be the subject of the formula, and I'm going to move everything over to the other side. So I'm going to have R is equal to 52 minus 12 minus 14 minus X. And then if we clean this up, 52 minus 12 minus 14, that's going to give me 26 minus X. So in the rugby column over here, I'm going to write 26 minus X. Can you guys use the same idea and find out what's for volleyball for me? Okay, we're going to put them all together and we're going to find volleyball. And remember, the volleyball circle will be this one over here. Okay, Oratile says 13 minus X. Okay, let's see if you're onto something. Does anybody else agree with Oratile? Okay. Equal to. Excellent. I agree with you guys. It's 13 minus X. All right. So volleyball will be 13 minus X. Excellent. Thank you, Ntokozo. All right. So we know that this is what our entire Venn diagram will look like. You will get your full 5 marks if this is how you filled it in. Just want to see if I can get rid of that. Okay. So full 5 marks for everything that happens in this. Okay. Now it says in question 8.2, show that X is equal to 8. Does anybody have any idea? How could we possibly make sure that X is equal to 8? How can we find out what X is? Anybody have an idea? Yes, Valerie, we would solve for X, but how would we solve for X? Okay. I'm seeing Nick saying 80 minus. Okay, can we have a bit more elaboration on what you mean by 80 minus? Good. Oratile says add all the terms together. Okay, and they must give us the sample. They must give us the sample size. All of them put together. Good, Ibrahim. Yes, we're going to add everything. Okay, so we're going to add up everything. Do not forget, and teacher Nelly will attest to this, I forgot about this number here, this 3 that don't do anything. Okay. Add them all up. Okay. So we're going to put 26 minus x plus 12 plus 5 plus 15 plus 13 minus x plus 14 plus the x in the middle plus the 3 on the outside. All of it must equal to 80. And then we're going to solve for x. Okay. But now this is what you're writing. Okay. The important thing isn't that at the end you're going to get the answer that x is equal to 8. What they want to see is this step. This is the step that they want to see, because they're asking you to prove or show that x is equal to 80. Okay. So if we do that quickly, we can add up all the numbers. I know that minus x plus x is going to cancel, and I'm going to have minus x left as my variable there. Negative x. The only thing left to do is to add up all the other numbers. So I'm going to end up with 88 minus x is equal to 80. And I'm going to take 88 over. Good. Negative x is equal to 80 minus 88, which would give me negative x. And therefore, x is equal to 8. Okay, well done, Oratile, that's correct. But remember, guys, they're not looking for the answer. They already know what the answer is. They gave you the answer. What they want you to follow is the steps. So you will get a mark, you will get your 2 marks for doing the correct steps in order to get to x is equal to 8. Okay, I hope that makes sense. All right, let's look at 8.3. How many learners like rugby only, or play, yeah, like only rugby? Oh, Nick, be careful. It would not be 26 plus. We need to consider that sign in the middle there. We need to consider the sign. Yes, is it Chai or is it Kai? I hope I'm getting your name correct. Do you want to unmute for me and ask your question?
Okay, ma'am.
Hi,
Question,
how do you
if
pronounce your name?
in the Venn diagram,
Yes, sir.
Kai,
Kai. Okay, hello, Kai.
the name is Kai.
Yes, in the Venn diagram.
Yeah, afternoon. Oh, if they don't like ask in the next question that you should show that x is equal to a certain number, should you like solve x in the Venn diagram?
I would suggest you do. And the reason that I suggest you do it is because there's a possibility, there's a big probability that it will come up in the questions coming up. Okay. They will most likely ask you something about the number of rugby only, and then you will have to solve for x anyway. Or they will ask you for the number of kids who like just like all 3, the kids who like all 3, that will force you to solve for it anyway. Okay. So read through the questions. If they don't ask for it, they're probably going to ask you to solve it inside another question. Okay. All right. I hope that answers your question. All right. Okay. So it would be 18, yes, because we're going to have 26. Let me write it here right next to it. 20. Oh, Lord, look at what I've done now. There we go. 26 minus x. And we now know that x is 8. That's 26 minus 8 is equal to 18. Okay, there we go. It's 18. All right. Okay, let's look at the last one. It says, calculate the probability that a learner chosen randomly likes at least 2 different types of sport. Okay. So if we look at the word at least, what does at least tell me, guys? At least 2. How else can I phrase at least 2? Does anybody have any idea how else we can phrase the word at least 2? Oh, it's not going to be the first two. Remember, they want the probability that a learner chosen at random likes at least two. So will that be? Oh, can you say something? I heard someone's voice. Ah, there we go. I agree with Nick and Emiche. Yes, it's two or more. Okay. Two. Okay, it means two or more. Two or more. So it could be two or it could be three. Sure, guys, I'm hearing a bit of an echo. Can I just ask everyone to mute just so we don't have an issue? Okay. It would be two or more. So two included and more. So which numbers would we be looking at? It would be the intersections of all of them, all of the sums, this one, the intersection, because if you like volleyball and chess, that's two. And if you like rugby and volleyball, that's two as well. If you like rugby and chess, that's also two. But the more would be if you liked all three, which would also be this middle part over here. So if we add all of these up over, we need to make sure that we're writing a probability. Okay, so we need to add all of them up. Can you guys give me a number? We're going to have 14 plus 12 plus 15. And remember, we figured out that our x is 8 plus 8. Okay, will give us a specific number. And because it's a probability, 49, good. Thank you, Nick. It's 49. Because it's the probability of two or more, we would have to put it over the entire sample space. So it would have to be 49 over 80. Okay. Do not forget, they're not asking how many learners. If they said how many learners like two or more, then you would just say 49. But they want to know the probability that a learner chosen randomly is two difference. Remember, is at least two. So if they were asking you how many learners, you would just say 49. But because they're asking for the probability, it will be 49 over the entire sample space. I hope that's making a lot of sense to you. Okay. Sure, I think I may have lost teacher. Oh, teacher Nelisa is here. Hi. Oh, imagine 3 marks down the drain. Yeah, they would probably give you 1 mark, Nick, for figuring out that it's 49 learners, but you wouldn't get any more marks than that because you wouldn't have told them that it's the probability. Ibrahim, if you can help it, unless they ask for a decimal, do not give them a decimal. Leave it as a fraction, because sometimes when we write a decimal instead of a fraction, we'll click that SD button and many other decimals need to come after that comma, and your calculator doesn't show all the decimals. And then your number becomes inaccurate. So rather keep it as a decimal, okay? It helps a lot if you just keep it as a decimal. All right. Okay, I'm a bit afraid to start a new question just for the sake of time. Can we do one more question, do you think, Teacher Nelisa? Maybe just one.
Just one.
Just one, yeah, just one. Okay. All right, and this one is a bit tricky, guys, so we're gonna have to think through quite a lot of this. Please, just the glasses emoji in the chat for me once you've read. Actually, let's not do that. Let's put the fire emoji in after we've answered question 1, for the sake of time. Okay, I'm just going to write here because I think I may be running out of space. My sample size is actually 100. My sample size is 100. Okay, so this is learners that play 3 codes of sport. They play S and V, they play soccer or netball or volleyball. Okay,
Oh, I forgot today is quiz day.
It is quiz day. Oh my goodness. I'd forgotten myself, actually.
Quiz day.
Sure, it is. In my class, we call them no stress or low stress quiz day. Yes, it is quiz day, Diana. Diana, the quiz is literally just to check for your understanding. You can do it as many times as you need to make sure you understand the concepts that we're learning here today. Okay. That's why we call it a low stress quiz. Okay. You're just testing your understanding. It's like a practice for all the stuff that you learned. Not compulsory, not at all. Excellent, Kai. Yes, you're correct. I also got 15. Okay, I'm going to give it 1 more minute and then I'm going to start writing down answers. It is kind of tricky. You're right, Nick. Nick says, okay, this one is kind of tricky. Not really, though. We just need to make sure we're partitioning it off properly. Okay, I'll tell you, there's a bit of a trick. And if you didn't read the first part properly, you may have missed it. Okay. I'm going to write up here in V. Going to start running out of fresh. Because I'm not sure how you got D as 1, ma'am. Oh, how is B1? I'm going to show you guys in just a bit. Look here. Look at what it says here in the instructions. Let me highlight it actually. Yeah, I missed it the first time myself as well. 2 learners play soccer and volleyball. And that's this intersection over here between soccer and volleyball. Now, we already have one player who plays soccer and volleyball. That means B has to be 1 because there are 2 learners who play soccer and volleyball. You guys see it now? I hope it makes a lot more sense. Yeah, see, that's why I'm saying if you didn't read all the information, you may have missed it. You may have missed it. B plus D plus 1 plus 2 is equal to 7. Right, and B is 1 plus D plus 1 plus 2 is equal to 7. Therefore, D is equal to 3, not 2. Careful, Pi, it's 3. Okay. And E is going to be what's left over. Yes, ma'am.
You only left with 4 minutes before the next class, so I was thinking you should.
Oh my goodness. Okay. Okay.
Yeah. Okay. I'm going to post the link to the quiz on the chat. Please do the quiz.
Thank you. I've completely forgotten about time. Thank you for that. All right, guys. To find E, we're going to take 100 and minus everything. Okay. We're going to take 100 minus everything that we have. So minus 15 minus, what is B again? Minus 1 minus 38 minus 3 minus 1 minus 2 minus 3. And that will give us E.